All right, so I've been reading up on memory and making some sketches, and I think I can explain the basics.
Okay, well, let's start with a definition. What is memory?
Like so many ideas in psychology, even though we all have an intuitive sense of what memory is, it's not easy to define.
So this is where the analogies come out, right?
Maybe. Not unlike what your computer would do, your mind processes information, and this, at the most basic level, is memory. The three main steps in creating and making use of memories are encoding, which is the process of creating a mental representation of something. How about you, your loved one, and a beautiful sunset? Storage. It's the retention of those mental representations you have encoded. And finally, retrieval. The recovery of your stored mental representations.
That does sound exactly like a computer.
Well, of course it doesn't happen exactly like that, but you get the idea. Psychologists usually categorize memory into three basic systems. Sensory memory. These are fleeting visual, auditory, and tactile memories of perceived objects. They last for a few seconds. Short-term memory holds and processes a limited amount of information, between 5 to 9 chunks of information. Short-term holds onto these chunks for up to 20 seconds, unless, however, the chunks are actively rehearsed so they can move onto long-term memory. Finally, long-term memory encompasses the vast amount of enduring memories like experiences and skills that are acquired over a lifetime. And, before I forget, long-term memory is broken down further into declarative memory, which stores and retrieves facts and events, and procedural memory, which lets us remember how to do things. Let's explore how and where our brains form memories to get a better understanding of the underlying brain structures and functions involved. Dr. Howard Eichenbaum at Boston University studies learning and memory. Let's pay a visit to his lab.
What is the brain circuitry that allows us to accomplish this wonderful phenomenon of memory? How do we encode these memories? How do we retrieve these memories? How do we organize them? How do we store them forever? How do we do all that stuff? How, in particular, how does brain circuitry accomplish that?
So, okay, let's start with maybe that. How does a brain retrieve memory? Is that a fair question?
That is an absolutely fair question, precisely the question that we're after. So the way in which we study this question of what is the circuitry for memory and how does it work, how does it accomplish what it does, is to first understand the anatomy of the brain. That is, what are the brain structures that are crucial to memory? How are they connected up with each other? That's the initial question. So we're identifying the characters, essentially, of the circuitry who are going to accomplish this task, the components, and how they're connected with one another. Then we have to get in and sort of start answering questions about function. What do each of those components do, right? And how do they cooperate to accomplish this big phenomenon of memory?
So the hippocampus, is that where your memories are stored, or is that a different area?
So that's a very good question. It's a terrific question. Lots of people ask that. Some people often speak of the idea that the hippocampus actually stores memories. It does store something. It certainly stores information. What it doesn't do, we think, is store those details of memories. What it does is it's sort of an indexer. Think of it as your local librarian, who doesn't really have all that stuff in the library. The library is like the cerebral cortex. It has all the stuff in all of its different columns and shelves by different topics, you know, in different places and things. And the librarian simply knows how to get all that information, right? So it does have information. The librarian knows the how or knows the where everything is. So that's what the hippocampus does. It stores these indices or locations of all the information in the cortex. So the entire system is complicated. It involves really numerous areas in the brain, particularly a large number of areas of the cerebral cortex, each of which process different kinds of information. So there are areas in the cortex that process information about perceptions, things like vision or audition and so on, things that process motions, things that process thoughts and actions. These are all different areas of the cerebral cortex, and they all funnel their information down to this structure, the hippocampus. And the hippocampus does something magically to help the cortex organize its information.
Kind of like a filtering.
It's sort of a collector, more so than it does do some filtering perhaps, but it's more a collector of all that information. It sort of binds it all together into the components of a memory, whereas up in the cortex, it's just identifying each of the little bits and pieces.
Yeah, and kind of sending it down to the hippocampus.
So the hippocampus is this organizer of the information that's in the cortex.
So what exactly are we looking at here?
Well, here I thought I'd show you how we collect data in one of the experiments that we're doing. So this is an experiment where we're attempting to examine how a particular brain structure that's very much involved in memory, called the hippocampus, encodes information that's crucial to the animal's performance in this simple memory task. So what's happening in this memory task, first of all, let me say, is we're looking at an overhead view of a black and white camera in a light-dimmed room, so it looks so grainy. We're looking down on top of a maze, a very simple sort of maze that the animal's going to run around and perform what's called a spatial alternation task.
Okay.
So the way the test works is the animal is, this is the rat up above here. He looks upside down. Here's his tail.
Yeah,
here's his
little
head.
tail.
Right,
Okay.
very good. He's going to run down what's called the stem of the maze here. He's going to turn in one direction or the other. I think perhaps this way first. He'll get a reward for doing so. So you'll see him stop here briefly. And then he'll run back this thing we call a return arm to the top. And then the requirement is that he alternates. So that means if he went to the right last time, now he has to go to the left this time, and he'll get another reward. And then he comes back this return arm to the top, and then runs down the stem, and then following the alternation rule, he has to go back to the right again, and up, and so on. So he sort of runs in a bit like a figure 8.
So this is kind of
around
measuring,
this maze.
can he remember which way to go?
That's right. So each time he's running down the stem, exactly, each way he's running down the stem, he has to remember where he came from. So if I came from the left side, I now have to turn right, and if I came from the right side, I now have to turn left.
And what kind
so
of reward
during
does he
this
get?
period, he gets sweetened water, which squirts
Hey.
up in a little bubble. We won't be able to see it, but the water comes up right here. And you'll see him sort of stop and pause there, and that's when he's drinking the water on each trial. He only gets the water if he turns correctly. If he turns incorrectly, he has to go back to the top and start over again.
Ah, okay,
All right?
okay, cool,
Now, on the audio section of this, we're going to be listening to a neuron, actually 2 different neurons. Crucial thing to look for is how the neuron that fires here is active. So this neuron is actually going to predict with its activity which way he's going to turn. So we're really doing a bit of a mind-reading exercise here where we're listening to an individual neuron in the brain, and we're going to be able to tell
And
by
from
that
that, you'll be able to
activity
tell
what
which way
gonna
he's
do. So you
going.
can see
Okay.
which way he's thinking about turning in the form of his neuronal activity. So if I start the little video running here, there we go. Listen closely. So that was the 2 neurons. One clicked a little bit here and then a little bit right here. That was the second cell. He's getting his water now. Now he's going to the top. Okay. That was the 2 neurons again, like that. All right, now I'll just let you listen for a moment.
Those are the...
So the question is, which one does it, if it fires more, which way is he going to turn? That's the question you should think about.
So if it fires more, I'm saying he's going to go that way, right?
Very good.
Aha!
All right, you got it.
We've covered more than just the basics.
Yeah, I really feel like I have a good understanding of how memory works.